Hello students, today we are starting a very important chapter, the atmosphere. It's basically the blanket of air that surrounds our earth and makes life possible. The earth is surrounded by a blanket of gases known as the atmosphere. It is held in place by gravity and extends thousands of kilometers into space. The atmosphere protects life by absorbing harmful ultraviolet radiation from the sun. The atmosphere is essential for life. It provides oxygen for respiration and carbon dioxide for photosynthesis. Nearly 97% of the effective atmosphere lies within just 29 kilometers of the Earth's surface. About 78% is nitrogen, which helps to dilute oxygen and prevents everything from burning too fast. Around 21% is oxygen, which you and I need for breathing and combustion. Then we have small amounts like argon and carbon dioxide. Now, carbon dioxide is only 0.04%, but it's extremely important. Plants use it for photosynthesis and it also traps heat to keep our planet warm.
Sir, may I ask something?
Yes, go ahead.
If nitrogen doesn't help in breathing, then why do we need so much of it?
Excellent question. Nitrogen actually balances the air. Without it, oxygen would be too reactive and fires would spread uncontrollably. So nitrogen acts like a stabilizer. Also remember, there's water vapor, up to 4% in humid places, and tiny dust particles like pollen, sea salt, and smoke. These are very important because they help clouds to form. Now, let's talk about the layers of the atmosphere. The first and lowest layer is the troposphere. It extends about 8 kilometers at the poles and 16 kilometers at the equator. This is the layer where all weather happens: clouds, storms, rain, snow, everything. Here, the temperature drops as we go up, roughly 6.4 degrees Celsius for every kilometer. The upper limit is called the tropopause. Above that is the stratosphere, which goes up to about 50 kilometers. This layer is calm and free from storms, which is why jet aircrafts fly here. The most important part of this layer is the ozone layer. Ozone absorbs harmful ultraviolet radiation from the sun. That's why we say ozone protects life on Earth. Interestingly, in this layer, the temperature actually increases with height because of ozone absorbing UV rays. Next is the mesosphere. It extends up to 80 kilometers. This is the coldest part of the atmosphere, with temperatures dropping to minus 100 degrees Celsius. It also acts like a shield because most meteors burn up here before reaching Earth. Above it, we have the thermosphere, also called the ionosphere. This is where temperatures rise sharply, even above 1000 degrees Celsius. It contains electrically charged particles that reflect radio waves, which makes long-distance wireless communication possible. This is also the layer where we see the beautiful auroras, the northern and southern lights. Finally, the outermost layer is the exosphere. It gradually fades into outer space, extending up to 10,000 kilometers. This layer has very light gases like hydrogen and helium. The outer part is influenced by the Earth's magnetic field, which protects us from solar winds. Now let's understand atmospheric pressure. Atmospheric pressure is simply the weight of the air above us. At sea level, it is taken as 1013 millibars. Pressure decreases as we go higher. That's why mountaineers carry oxygen cylinders. Also, warm air is lighter and creates low pressure, while cold air is heavier and creates high pressure. Because of unequal heating, the Earth develops pressure belts. At the equator, hot air rises and forms a low-pressure belt called the doldrums. Around 30 degrees, the air descends to form the subtropical high-pressure belt, also called horse latitudes. At 60 degrees, warm and cold winds meet, creating the subpolar low-pressure belt. And finally, at the poles, cold dense air sinks to form the polar high-pressure belt. So in part 1, we've covered the composition of the atmosphere, its 5 layers, the concept of atmospheric pressure, and the system of pressure belts. In the next class, we will talk about winds, rainfall, cyclones, and clouds. That's where the atmosphere really comes alive. That's all for today. Jai Hind.